So can you folks hear me? Any thumbs up? Can people? Okay, so people can hear me. So my presentation is going to be about the programming language R. Particularly, I'm a guy from backend development that migrated towards data science, and I want to show you folks some interesting things that I adapted from my years as a software developers. As a software developer, and adapted it to the data science, application. I described a lot of things here, so there's not much time. There's a lot of ground to cover, so let's get to it. My main motivation was that I'm pursuing actually currently a master's degree. I know a lot of folks who don't usually folks that use R, many times they don't know many techniques or packages they can use to ramp up their development speed. So this presentation is going to be essentially about it. So let's get into it. First thing I'm going to talk to you guys about is about projects. Projects are like this little files called rproj, created by RStudio. By the way, this whole presentation is going to be using RStudio. It's an open source IDE for R that, in my opinion, it's a lot better than the standard GUI shipped together with R. So, all right, so you whenever you have a rproj file in a folder, it sets the working directly to be specifically to relative to that directive. So if you're working with a team, that's actually a very good practice to have. Okay, so let's do some analysis. We're going to need a file. Let's code the R. All right, so here we have a file. Let's do some analysis. So you use R for that, right? So let's say you have the Iris data set. Are you guys familiar with that? Very famous in data sciences. Let's suppose we want to create a sub-iris with an analysis on the species. I want to select all the lines which correspond to a species versicolor, for example. So I would do iris species and equals versicolor. All right, cool. So I have some subset. Now suppose that I want to plot a sub-iris with a sepal length together with sub-iris sepal width. Okay, so here I have my plot. So suppose I want to now plot sepal length versus petal length. I can do that too. I can also do versus petal width. All right, so let's suppose I want to see all of these guys together. I can do an older trick called mfrow, in which I can set multiple panels in order to plot all of these guys at the same time. So, all right, and there we have it, our plot. Now, suppose I want to do that for other species as well. I could copy and paste code, like Setosa is also a species. And yeah, it generates me a different data set. So okay, the main focus about this, if I want you guys to take away one thing from this presentation, is how to use functions to organize your code. So the way you create functions in R is you create a variable. For example, let's say plot species, something that a function that takes a species name and this analysis. And we don't need this anymore. We want to use here the species name. And I think that's it. We create this. Now we directly could replace all this code with plot species versicolor. And yeah, yields me the same result as before. So now, if I want to plot the other species would be plot versicolor virginica and setosa. Cool. All right, so here's the first takeaway. We plot. We organize our code, the portions of code that repeats into functions. Usually people tend to overlook this because you only repeat so many times, like maybe 3 to 5 times, but this really helps you clean up your code. So it's a good thing to have. And let's see what else. Oh yeah, we actually can clean up this code a little bit better. Can you guys see that I repeat this sub-iris thing here actually 1 to 6 times in these 3 lines of code? There is actually a way to avoid repetition of data sets in R, which is with the with function. So if I use sub-iris here and pass in a block of code, I can actually copy and paste these folks here, and that allows me to simply remove the references to the parent data set, and that in turn allows me to write cleaner code. You see, like a lot of small things that combine together help you clean up your code, so that's a good thing to get in mind. Now let's see if we can handle a little bit of messy data. You guys know about the R quality data set. It's a data set that comes together with R, so it's good for presentations like this. If you guys want to try this code at home, it should just work. Okay, so let's say I want to see how it behaves. So summary, R quality. So here it gives me a summary about all the columns in the data set. And suppose I want to I don't know, maybe plot this, a cool function to analyze a lot of a relationship between items in a column is using the parse function. It plots a cool pane like this, and like with each variable in the x or y axis. And you should read the documentation about it anytime. You can access documentation with a question mark and parse like this. All right, so that's good. All right, so that's actually too much data. Let's say I want to just plot ozone, solar, wind, and temperature. So the way I would do that is like sub R is R quality with all the rows, and I want to select just ozone and solar. Or, by the way, variables in R accept dots, so they have no special meaning. Actually, they can have some special meaning if you are dealing with object orientation in R, but that's primarily just a name. So you can have variables with dots in the in your code. Wind and temperature. Cool. So now let's run pairs over this guy. And okay, so let me zoom this guy a little bit. I don't know. There are many few points here, so I don't know. Let's filter out the ozone to just select the points which have ozone value less than 100 subset. sub R, in which I select ozone less than 100. By the way, this subset function, it it works similarly to the width function, in which you can refer to the columns without actually being explicit here. So ozoneless, and like this, and if I parse this, and all right, cool. So it's a little bit cleaner, and okay. So, but this is a little bit ugly. I'm declaring a lot of variables for intermediate steps. So one way to actually solve this problem is to use something called Magritte, which is the pipe operator for R. R is actually a very flexible language in which it inherits from Lisp a lot of behaviors. One of them is to manipulate the surroundings of the code that you invoke. And one of the cool things about this is this little piece of software called Magritte, which allows you to write code like this. Our quality, pipe operator, special defined operators are always defined in percentage signs, between percentage signs. So I want to select the columns ozone. This code is right over here. I will just copy it over. And okay. So yeah, it's working now. I want to. Oh, so by default, it always picks up the previous argument from the pipe and puts it inside as the first parameter, unless you specify a dot, in which case you actually replace the position of the value by the dot itself. So you can actually use it to write code like this, and because we want to pass it to the next function, we actually plot the same thing using much less code in a much more intuitive manner. The way this function, but notice this uses a lot of specific R functions in which you have to be a little bit knowledgeable about the R universe in order to know about them and how to use them. They're good, but there's actually something really cool called Plier, which is made by the same company that makes our studio. The guys are really awesome, and it exposes a lot of idioms that allows you to manipulate data frames, which you can think of data frames just like Excel spreadsheets. So you have like a bunch of columns with rows of values. Okay, so if I were to achieve this same thing in the Plier, I would do the same thing, our quality. Afterwards, pipe it into the select function, which I can just expose ozone, solar. Oh, by the way, because it integrates with R, you have autocomplete here, so it's like really helpful. And then I want to filter ozone with less than 100, and I finally want to use it to parse, and gives me the same result. Cool. What else can we do with it? Do you guys know about group by? What if we wanted to, I don't know, maybe calculate the average ozone per month? So I would do that with, because like the idiom of Plier is more natural. They like speak well together with each other. I can do something like this, for example, group by month, group by month with a capital M. There we have it. And after that, I want to summarize by ozone equals mean of ozone. Cool, so what? We have a lot of NAs. Actually, that makes sense, because if we try to calculate the mean of like 1, 2, 3, it gives me a value, but if I include an NA, it actually makes the whole value return an NA if I actually inspect the air quality data set. I'll take a look. I'll notice there are a lot of NAs here in the air quality ozone column. And in order to get around this, here notice, a lot of times when you deal with data sets in the wild, you actually find a lot of NAs and things that make your code break. So yeah, so this is just an example of how you can find errors in the wild. So actually, Plier makes it somewhat easier to deal with these things. So I want to, for example, one way to solve this is I want to filter all the values that aren't NA. NA is a function which returns true as the values if the value is an NA, and I can actually put like this. Then yeah, works. Another way to solve it, actually, a lot of functions in R accept this parameter, which is the parameter na.rm, which is remove NA, and we set it to true, and yeah, works, gives me the same result. Suppose you want to view this in a little, better visualization. Suppose you actually have like a large data set. You can use a little function called view, which opens up a window in our view with a capital V. It opens a window inside RStudio. This, I believe it only works in RStudio itself. And you can actually explore bigger chunks of data. So for example, if I wanted to explore air quality itself, it will allow me to actually order things here and like to actually take a look on how the data behaves in this data set. And okay, so cool. How do I learn more about R, about Plier? You can actually execute the documentation for the actual function that you're using, but I'm not that big of a fan, because if you're a total beginner, you don't want to look at documentation of the function, you want a tutorial. So there's this thing called BigNet, in which you can actually call up the name of a BigNet, and it opens up the tutorial, and that's installed together with the packages. So let's say you want to explore all the VNets in your that are installed in your environment. Oh, those are too many. Okay, so I want only the VNets from the package Plier. Oh, those are less. I think introduction to Plier, I think that's useful. So if I just type VNet Plier, okay, gives me useful things. I can open it in an external window and take a better look at it. So this is good too. Does it work for Magritter? I don't know. Yeah, it does. Oh, cool. All right. Convenient, huh? All right, so, okay, but do you guys notice that these verbs, do any of you guys work with SQL? Do you guys know SQL? So yeah, so SQL is a language that is used to query databases, and to be fair, there is not much difference between making a query to a database and handling a data set. You actually use many of the same verbs in order to talk to tabular data, and actually there's this really cool thing called dbPlier, which converts dplyr language to actual queries, which you can use to query against your database. So in order for this presentation, I created a Docker file with a Northwind sample dataset from loaded in Postgres database. So I'm going to run this image. It will load a lot of data. That's a lot of lines. But it's finished. So now we can actually connect to this database. And the way R connects to database is using a package called R, PostgreSQL, and using the standard interface for DB connections inside R, the DBI package. And actually, let's create a new connection. So DBI, two columns, and by using two columns we can actually use a function of a package without actually requiring the package and importing all the environment of that package into our current workspace. So that's useful if you just need one function of that database. So okay, so DB connect, we want to connect to our PostgreSQL. PostgreSQL. I want to use a PostgreSQL driver, and I want to use host equals localhost because it's a Docker image. It uses the standard USB port. I want to use user. For this image in particular is Northwind user. The password, of course, is a top secret. So I'm going to use a special function to ask for the password for a studio, db password. By the way, you should never, ever write your function, your password inside your code. Gnomes are going to hunt you at night. And db name equals Northwind. By the way, the password is the wind is blowing. Don't tell anyone, please. Northwind. Okay, so if I execute this code, asks me for the password. The wind is blowing, and we are there. So how do I know which tables are there? DB list tables. I pass in a connection. Oops, and there we have it. So okay, so I want to query, let's say, the orders table. So I create a reference to that table, orders and table, TBL. I pass in the connection and the name of the table. So there we have it. So if we actually inspect this, we actually query the database. And the best of all, we can actually, by the way, just a quick notice here. DB Plier tries to be as lazy as possible and only queries the database whenever it needs to show you actual data. So, for example, when I created this line of code, it didn't actually do any query because it just queried the columns that it does for the auto-completion thing, but it didn't actually get any data. But I can actually use it to, I don't know, maybe filter customer ID equals, I don't know, this guy over here. And I want to, I don't know, maybe count. And yeah, all right. What query does it yield? Show query. Oh, cool. It actually generates a very reasonable query. Okay, so yeah, I can actually replace very complex or idioms that are translated to SQL queries, and this is actually very convenient. Okay, so suppose I wanted to get all the distinct customer ID. Auto-completion is nice. And I want the first 5 elements, and I want to convert that into an actual object. For that, I use the collect function, and I want to save that into a variable. Now suppose I want to go back to the table orders and filter customer ID in IDs, which is the values that I took just earlier. And then I want to group by customer ID, and I want to summarize average equals mean freight. Oops. Where's the freight? Here it is. So, oh, look, a warning. By the way, this is just a warning for you to know that the R handles new values differently than SQL does. When using aggregate functions, SQL simply ignores them and computes the value anyway, whereas R make the whole data set be null. So the way you suppress that warning is doing exactly what we did earlier. So use method applicable for skip sequence. And then oops, average mean group by same values are always removed. Okay. Summarize. Customer ID in IDs. I'm not sure exactly why this warning message is showing up. I'm going to publish a reviewed version later in my presentation slides. I'm sorry for that, but the point here is that you can actually use this to generate SQL queries for you, so that is convenient. Let's go on to the next topic because we're running out of time. So, data science, some people use R for it, some people use Python. Do you guys know that Python and R can actually talk to each other? There's this little package called Reticulate, which actually manipulates Python code directly from your R session. So you can do cool things just like import pandas. And I can actually create a data frame. Oops. That receives a dictionary, but there is no dictionary in R, so I have to pass in a named list. So list with x equals 1 to 10, and that is converted to a regular data frame in R. So it translates data frames to R data frames to pandas data frames, vectors, R vectors to NumPy vectors. So it tries to be smart about the most common use cases for data science. And actually, you can take a look about the different. Oops. The different ways of calling here. There is this practical table which explains you everything. And by the way, that whole document explains you how to use the remainder of the functions. So PyrinString is another way in which you can use to actually run Python code. For example, if we were to use the same thing, pandas as PD, and data equals PD, data frame x range 10. For example, if we were to execute this guy, I would be able to access the objects created inside the Python session by this py object, and it has the data that I just created. So yeah, so if you have like a Python package that solves your problem, you can actually use that from within R. Very convenient. What else? Let's see. Oh, okay. So let's suppose a different use case. You have this. You have this function that always combines, for example, subsetting and using parse. We could, for example, refactor this code in order to make it to a function. Let's call it select pairs, in which I specify a data set and columns, which, function, and after that I do sub equals data, in which I just select the columns that I just received, and after that I call it within parse. By the way, I'm using the R native functions because the goal is this function to be able to be used in any R session, and I don't want the guys who needed to just install any dependencies. So it's just for teaching purposes. So sub, and I could, for example, take this piece of code here. I could remove this and then pass it into select pairs using this function, and then that will be a way to simplify. So yeah, so we got the same example as earlier, but suppose my friend wants to use this function that I just created. I could create a package for that. I can come here, new project, save, new directory or package. I want to create select pairs package. In the project folder, create a Git directory for me, create project, and loads a new session. What you need to know about an R package is it loads functions inside the R folder. So if it's a file inside the R folder, you can actually just paste it here. I build it. Cool. So now I can library, select pairs, and it loads my package. Cool. But how do I share it with others? Okay, I could publish to the official or registry, but that's like that requires your package to be fully documented. You have to have tests and support for all major platforms. And suppose you just want like a quick and dirty package to share with friends. This way you can use install packages from GitHub. So Hub create is by the way, Hub is a command line utility from GitHub, which integrates with Git. It's very awesome. So first commit and git push origin master and da. All right, cool. So let's get back here. I want to open my project, my old project again. So okay, now suppose I want to use that function here. I could use a package called DevTools. By the way, you can use that to create a package without R. I won't get into much detail because we don't have much time. And I can have a function called install GitHub, in which I just pass in a folder, in my case Thales Mello, and select pairs, and it's installing. Okay, so you can just like share that line of code with a friend, and your friend can actually install your package. You can submit updates, and your friend can then get the updates. It's very useful for development. So cool. So now you know how to create reusable R packages. What else? Now about a cool little feature of RStudio called Snippets. You guys possibly use other editors for other programming languages, but RStudio is very good for dealing with R. By the way, you can actually use VI mode in the global options here. I won't get there because we don't have much time, but the thing here is you can actually use snippets. There are a bunch of snippets installed built-in. For example, if I press Shift Tab, it expands to a condition. I don't know, true equals true. Or I want to create a function more quickly. Fun, Shift Tab, and it creates the function for me. Oh, I have a specific pattern that I want to support. No problem. You can go to Tools, Global Options, Code, Added Snippets, and here you have it. By the way, RStudio also has support for other languages. If you have like a problem with a slow portion of your code, you can use something called RCPP to make faster functions. That's really awesome. I'm using in my master's degree research, but anyway, I won't cover this in this presentation. And okay, so now you know how you can create new snippets and how to use snippets. Okay, what else? There are add-ins actually. You can, there's this thing called Addins. Browse add-ins. Here you can see all the add-ins that some of your packages installed. You can click here to learn more. It takes you to like a page with just developer API, not very useful if you just want to use something ready. So for that, there is actually this other package, which is actually an add-in itself, which works like a registry for custom plugins. Once you install the package, you can browse RStudio plugins, and then you can install things directly from here. Some of my favorite are, for example, suppose this code is badly formatted, and I want to format it. There's this add-in called Styler, in which I can style a selection or a whole package or just a file, and that's useful. But I also do have a very cool add-in called Data Pasta. How does it work? Let's suppose we have like a table like this one from Reticulate. I want to manipulate that in R. So if I actually need to do that, I can come here, data, and use this add-in called Data Pasta, paste as tribble, and actually pastes the code in a format which becomes a data frame in R. I can access the same variables from that page. So that's actually a very useful add-in that can speed up time. Oh, we also have another one for a more advanced use for R Markdown. Do you guys know R Markdown? Let's create, for example, an R notebook. What is an R notebook? It's a Markdown document which is combined with our code. So I can actually execute code inside this, and it actually displays everything in line. So actually, I can export this to HTML or PDF. Oops. There we have it, like an HTML document. But suppose we want to use we want to input an equation. If you actually do research, that's actually a very common use case. If you need to input equations, you can use this add-in that comes with the extension bookdown. You come here, bookdown, input Latex Math. Let's input the Bhaskara equation, which is minus b plus minus and square root with b squared and minus 4 times a times c. Then we select all of this. Oops. We divide it by 2a. There we have it, and it inputs the equation here, we can actually compile it, and it becomes a part of our report. Now, if you are in academia, a lot of times you have to deal with images and references to equations and references to plots. And to be pretty sincere, our Markdown has such a nice syntax, but isn't very knowledgeable about references. You can actually do that with something called Bookdown, which is this plugin that allows you to create books using Markdown notation. But in case you need, for example, to write an essay or a short document, you don't want to write a book. You just want like a piece of paper with references to other parts of code. So if you actually want to make use of that, you can use. It provides you something called HTML document, which is a function which formats the code that you're passing it. So you specify this function for it to be used to render the document rather than the original Neatwire package. Neatwire is the thing that makes it possible to combine R packages and Markdown documents. So you put this in order to disable table of contents, and suppose we want to actually make a reference to this equation. Actually, there's a whole lot of documentation inside the Bookdown website, but if you actually do something like this and equation and create a special reference like equation Bhaskara, like this, and you reference it somewhere like there is equation reference equation you actually get references inside your documentation. You can do that for references in portions of your text, for segments inside your for example, suppose you have like another cool thing it does automatically is suppose you have like a first and second segment of your article. You can actually, it's awesome. You can, it creates like numbered sections. If you want a table of contents, it generates a table of contents for you. So yeah, it's cool. You can combine it with our plots, for example, plots 110 and 10.1, and that becomes part of your document. Now we don't have much more time. There are other cool things you can do. For example, refactor code. Suppose you want to rename all the PD instances for I don't know, maybe pandas by full extent. You can find all and then, for example, type pandas. Makes it easier to refactor. What else? There are actually a whole lot of useful packages which I'm not able to explore here. There is like ggplot, which is very useful to create very complex and beautiful graphics. Plier is the thing that we covered extensively here. Plier is like an alternative representation for data frames. Readr is something that allows you to read CSVs and tabular data from directly from disk much faster than the native R functions, and they infer types of columns automatically for you, so it's really awesome. You will save a lot of time if you deal with lots of of packages. Pure is like a package that R is already a functional language, but this pure package has like the missing pieces for functional programming in R. Tibble, I don't remember exactly what's used for. Stringer manipulates strings. For cats, it manipulates categories. What else? Read Excel allows you to read Excel documents. Haven, in case you work with SPSS, as data, or SAS data. You have packages to manipulate JSON, XML, HTTP, make HTTP requests, do web scraping. That's a whole lot of cool things. Liberdate for dates and blob for binaries. Guys, that's it. Migrator, which we covered in the function. Yeah. Take a look at tidyverse and have fun. Peace.